Hey everyone, and welcome to another deep dive. Today we're getting into something that's really got people talking. Blockchain, but for data management.
Yeah, it seems like it's everywhere these days.
It really does. In this paper we're looking at, a blockchain-based secure framework for data management. It gets into some really interesting applications, especially for anyone interested in things like aviation, drones, the future of data storage, all that.
Definitely, there are a lot of people trying to figure out where all this fits in.
So let's just jump right in. This paper doesn't waste any time getting to the big challenges with data management today. Um, One of the examples they use is drones and flight data recorders.
Okay, so we're talking like black boxes for drones.
Exactly. And they actually mention a company called Red Cat that's already developing these blockchain-based recorders. But think about it. You have these tiny devices, and they're collecting tons of data. So the big question is, how do you even store all of that?
Yeah, that's always been a huge limitation, not just with drones, but anything in the Internet of Things. All these devices, sensors, they're generating data nonstop.
And it's not just the storage, right? What happens if a drone loses connection mid-flight? That data, which could be really important, it could just disappear.
Right, and trying to recover that with traditional systems. Good luck with that. It can be a nightmare.
Which brings us to the other big issue, security. You mentioned those flight recorders. Well, imagine a drone crash. That data needs to be secure, tamper-proof, and easy to access for investigations.
Absolutely, and it makes you think about things like that drone chaos at Gatwick Airport a few years ago. All those disruptions, the grounded flights, thousands of passengers affected. This paper actually argues that blockchain could be the answer to managing drone traffic securely and making sure something like that never happens again.
So we've got storage problems, unreliable connections, and security risks. And if that wasn't enough, they throw in data overload on top of everything else.
Right.
So what exactly do they mean by data overload, and why is that such a big deal?
It's like we're almost drowning in data, right? It's not enough to just collect and store it. We need systems that can actually make sense of it all.
Right, like what good is all that data if you can't do anything with it?
Exactly, especially when you need insights in real time. Think about air traffic control trying to prevent a collision, and they've got thousands of drones in the mix. If they can't process the data fast enough, it's useless.
Okay, so we've got these massive challenges, but the researchers aren't just throwing in the towel, right? They actually propose this new framework using blockchain. And it all comes down to something they call clusters.
Right. Have you heard that term before?
Honestly, it sounds kind of sci-fi to me.
A little bit, yeah. But it's a really interesting concept. So instead of treating the blockchain like one massive storage container, they suggest creating these smaller, more specialized data groups. And that's where the clusters come in.
So instead of one giant blockchain trying to do it all, you've got these smaller blockchains all working together. I'm trying to picture this. It's like having different departments in a company, right? Each one manages its own data, but they can share information when they need to.
That's a great way to think about it. Like, you wouldn't store all the files on your computer in one giant folder, right?
No way. That would be chaos. You've got your work stuff, personal files, photos, all organized.
Exactly. And that's kind of what they're going for with these clusters.
Okay, that makes sense. But how does that actually work with blockchain? Do you need a separate blockchain for each cluster? Because that seems like it could get really complicated really fast.
Well, that's where it gets really clever. They combine on-chain and off-chain storage. So think of the blockchain as a really secure vault.
Right.
You know?
I'm with you.
You wouldn't keep everything in there, just the most important things, right? That's the on-chain data, like transaction records or those digital proofs we talked about. But then you have other stuff, your everyday items, and that's where off-chain storage comes in.
So it's like having the blockchain as this secure ledger, but the bulk of the data is actually stored somewhere else.
Yeah, it's like a secure warehouse that's still linked to that vault. You can keep those larger data sets there, like all those detailed sensor readings from a drone or historical flight data. That way you're not clogging up the blockchain.
Okay, that's pretty neat. So you're keeping the blockchain lean and efficient, but what about data from outside the blockchain? Like a drone needs to know the weather, right? You can't have a weather station on the blockchain.
That's where Oracle contracts come in. It's a way to bring in external data securely.
Hold on. Oracle contracts. Now you're just messing with me. It sounds like we're back in the Matrix.
It's not that complicated. Think of it like a trusted intermediary.
Okay.
So the blockchain can interact with things like weather stations, air traffic control, anything in the outside world, and pull in that information without compromising security.
So it's like a secure pipeline feeding data to the blockchain.
Exactly. But of course, you're right to think about the security of that data. How do you know it's reliable? What if someone hacks into the weather station and feeds the blockchain bad information?
Right. That's what I'm saying. It has to be more than just a pipeline.
Oh, absolutely. And the researchers have thought about all of that. They designed this framework with security as the top priority.
Okay, so they've thought about security, but what does that actually look like? I mean, it's one thing to say it's secure, but how do they actually make sure no one can mess with the data?
Well, it all comes back to how blockchain works at a fundamental level. Remember, we talked about how each node has a unique identity?
Right, like a digital fingerprint.
Exactly. And that's crucial for these Oracle contracts. They use something called public key cryptography. So it's like each data source has to verify its identity to interact with the blockchain.
So it's like trying to get past a high security scanner. You can't just fake your fingerprints.
Exactly. It's incredibly difficult. But even if someone did manage to get past those initial security measures, there are other safeguards in place. Remember how we talked about roles within those
Right,
clusters?
so not everyone has access to everything.
Exactly. So even if someone got their hands on some data, they wouldn't necessarily be able to do anything with it.
Okay, so it's like limiting the damage even if there's a breach.
Right. But it goes even further than that. They use this model, STRIDE. It stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege.
Okay, that's a mouthful.
Yeah, it covers a lot. But they use this to analyze their framework and look for vulnerabilities to all these different types of
So
attacks.
it's like they're trying to hack into their own system before anyone else can.
Exactly. They thought of everything, like what if someone tried to flood the network with fake requests, a denial of service attack, but the way blockchain is designed, it's really hard to shut down. There are just too many points of access.
Wow, so they've really thought of everything. So much to unpack here. We've covered data management challenges, this new framework with its clusters and Oracle contracts, all the security measures. It's a lot to take in. What are the key takeaways here for our listeners, even if they aren't, say, drone pilots themselves?
You know what's so cool about this research? It's bigger than just drones and aviation. Think about healthcare records. This could revolutionize how medical data is stored and shared.
Oh, wow. Yeah.
Or supply chains, where you could track every step of a product's journey. Even voting could benefit from this kind of security and transparency.
It's like a whole new world of trust and security online. Knowing that your data is really safe, and that's something we all want, right?
Absolutely. It's about building systems that are both efficient and secure.
Well said. A huge thanks to everyone for joining us for this deep dive into blockchain and data management. We've explored some really complex ideas today. Hopefully you found it as fascinating as we did. That's all the time we have for today, but we'll be back soon with another deep dive. Until then, keep those brain waves buzzing.